All righty. Did you guys have a good holiday? I'm sure any break from school is good, right? All right, this morning we're going to talk about the Swiss Army knife of cybersecurity. It'll do everything. Netcat. Anybody heard of it? No? Oh, it's evil. You'll love it. So, what Netcat does is think of it as kind of like a super utility, okay? You can literally take it and use it on one machine as a super server, okay? So like, let's say, we've got our evil hacking machine that we're hacking from, right? And this is our infrastructure that we want to have the files that we steal or whatever, the information we're trying to exfiltrate from the victim machine. This is how we want to send them back, right? So we'll stand this thing up and we'll tell it to listen on a certain port. And basically you can connect to that port and you don't have to have any protocol. You just do it straight over a raw socket. So that's what makes it so cool, is you can get it past a lot of stuff. So I'll just show you kind of on this one here, make it a little bit larger. And to use this, to play with it, you'll need to have two machines. You'll need to have your infrastructure machine, which would be Kali, and then a victim machine, which would be Ubuntu, or Windows, whichever one you want to abuse. It's typically easier to just set up two Linux machines side by side and go to it than trying to get a Windows machine, because you'll have to like disable stuff on Windows to get it to allow traffic out. All right, so it's a real simple command, NC for Netcat. Okay, so it's probably the shortest command you'll use. All right, but if we just do NC and help, I think it'll just take help. If not, what I'll do is put a dash, yeah. All right, it's got a lot of commands you can put, or switches you can put with the command. But basically what you do is you're going to set it up with Netcat, what you want it to do, like listen, okay? The port number and anything else that you would need to do what you're trying to accomplish. So if we look down here, you can see there's a -L, okay? Lowercase l. And it says listen mode, and it listens for inbound connections, okay? And it's really that simple. It listens, and it'll do whatever you want it to. So if we were to start a listener on this one, you just type in netcat -L and the port you want it to listen on, okay? And if you don't put anything else in there, it defaults to TCP. Okay, remember we got TCP and UDP, okay? TCP is the one that takes, does all the transmission control stuff, right? It does like, hey, I want to talk to you. And the other guy says, okay, I'll talk to you. And then you say, okay, let's talk, right? Okay, UDP is just fire and forget. Like your streaming games, like if you're playing a game on Xbox or your computer, doesn't matter. If it's a real first-person shooter or something like that where you're playing with 10 other people, it's using UDP. Okay, because it just fires a packet out and it doesn't care if the other end gets it. This is why you can still play if you're dropping packets. Okay, it may get a little jittery, but you'll still be able to play the game. All right, so let's say we want to listen on port 123. That's a nice port, right? That's it, it's listening. We're done. Okay, we've set up a server to actually receive whatever data we're sending. Okay, so It's a lot easier than setting up, say, a web server or an SSH server or anything like that. And what makes this really cool is it doesn't care what we send it at all, okay? So if we go to a victim machine, and let's see, well, I need to know what this IP address is first. 2.156. All right. So if we come over here and we just try to use any command and connect to that port, like let's say, I don't know if telnet's on here or not. Telnet to 190, go away. Telnet 192.168.2. What did I say? 156. Okay. Now, if you put a, let's see, I think it's a colon with this, and we put 123. Nope, it needs a space maybe. There we go. Okay, we've connected with Telnet over port 123 to the attacker machine. Okay, now if you look down here in the bottom left, okay, you can see it just says, you know, it's still blank, right? But what if I was to just type in some garbage over here and hit enter? Oh. Okay, so theoretically, you know, we're connected, right? And so I could just type in, you know, hi, and it's there. Okay, so anything I type on the victim machine now is being echoed to my attacker machine. Okay, so if you're, you know, say doing a pen test on this machine, you need to keep a record of everything you do, right? So that you can, you know, be able to turn that in at the end in your report and say, yeah, I was able to compromise this machine, get on it, and steal the family jewels and bring them over here, right? So everything you type on here is now on that machine. So like if I was going to run a command over here, I could just type in time or date, and then the command, okay, and it's going to tell us whatever we're doing over here is going to be echoed over here. So let's see, it won't run commands from here, so we'd have to copy and paste it over. But we can also go the other way with it. Like let's say we were working with a teammate, okay, and our team was pen testing this a company. Okay, we could actually set one of these up and do chat. So, you know, I could sit here and say, you know, do LS. And then you come back over here and it says do a LS. So it's like a real simple chat. You know, it's almost like having instant messenger, but, you know, it's faster. So, all right, so let's kill this one. See if we can kill it. What was Telnet's kill command? Escape character is... Yeah, let's see. Nope. Let's see. Should have used SSH. Should do it that way. Or here. We can kill it this way. Close terminal. Okay, so that'll kill it. So what else do you think we could use this for? I mean, just think about it. I mean, what are you going, you know, if you're pen testing something, what do you want to do? You want to get the critical information, you know, the company's crown jewels. You want to get those off the computer, right?
Could you, like, sneak on somebody?
Huh?
Could you, like, listen in on, like...
Not in that sense.
I think you actually listen to computer. I mean, it might be hard to actually listen to them. You maybe watch them.
Yeah, I mean, like, you know, every laptop has a camera, right? And supposedly, there's a little light on there to tell you when the camera's on, right? You can turn that off. So can the bad guys. So, like, no, not at all. And,
Wait, you should show us how.
No, I think that would get you guys in trouble.
Take a picture of everyone in the school.
For educational purposes.
Yeah, educational purposes, exactly. So, This right here is more for getting things to and from a machine. Okay. Now, yes, you could record. You could turn the mic on and record everything that the person or the environment where the computer's at. We've done that many times where you just sit there and have one machine as a listener, and it's listening to a room. So, like, let's say it's in a conference room, and you got 10 people in there discussing some sort of business stuff that if it got out would be bad for the company, right? Yes, you could record that, and you wouldn't be able to listen to it over Netcat, but you could take that recording and send it over Netcat. You could send files over it, okay, or the contents of files. There's a lot you can do with Netcat. The easiest one to do, though, is just setting up a listener and then transferring stuff, moving data to and from Netcat.
Can you, like, is there, I guess probably is a program where you can see what they're seeing? Like, through another monitor?
Oh, yeah.
See what?
Yeah, I mean, like, literally, you can screenshot, take output of this, okay? See how this is hooked up right here to the TV? Okay, you can take the output of a computer and send it to another device, okay? At the same token, you could record the screen and the keyboard strokes and the audio. So you could basically spy on somebody real easy by doing that. That's very common on cell phones. Your cell phones, whenever they're compromised, they typically you'll need to check that because the bad guy is going to do that.
How do you check that?
I mean, a lot of people have tools like you can buy antivirus and EDRs, endpoint detection and response software for your phones. There's free stuff out there as well, but I would definitely do that because your phones are not safe at all. No matter what the manufacturer says, they are completely unsafe. I mean, unless you've bought software to specifically protect you, what comes with your phone is not going to help you at all. Same with your computer. Once somebody gets on the computer, and they can do this very easily, I mean, we've discussed this a couple of times in here, but the easiest way to get on a hack or compromise someone's PC is a phishing email. They send you an email like we did with Beef, and you click the link, and at that point it's game over. They pretty much own the device, and anything you do on it will be, compromised. So if you're doing your banking, guess what? They're seeing all that information. They probably wouldn't be able to log in with just your username and password because most banks are going to have you use multi-factor authentication, right? A secure ID token or on your phone. Let's see, I got two of them on here. Like here's Google's. Bless you. All right, here's Google's Authenticator, right? Every time you have an account that you're going to access, you scan the QR code and it sets it up. So whenever I go and I log into my bank, it says, oh, I need to know the code. So then I got to have my phone, okay? Pick my phone up, find my bank, and then type these 6 letters in. And then it'll check and validate and authorize me to get on, okay? So that protects my bank account, right? But the bad guys, if they don't have one of these, they can get your username and password, but they're not going to be able to do a whole lot. But the bad thing that you got to worry about is if they're already on your laptop and you log into your bank and you use your multi-factor authentication and you get in, they can take the session key, okay, that is established and use that session key to get in and start another session that you don't see and, take all your money. So got to be careful with that. So we've learned a lot about tools for doing reconnaissance and tools for now moving files around and trying to exploit vulnerabilities. With Netcat, it's just another tool in your toolbox, right? So this is allowing you to move data. So if we were to go over to our victim machine, and let's say that we got on here, and let's see what we got in here. Is there anything in there? That's not giving us a whole lot. There we go. This is a big file. All right, so let's say we've got this file, and that's a super secret file that we need, right? And we're the bad guys. We can start our listener up over here, and we can put this on port 80 and make believe it's a web server, right? So, you know, if you're pen testing a company, and they probably allow port 80 and port 443 out, right? They probably allow that, because how else are you going to surf the web? How else are you going to go to, you know, a vendor and check their website or their catalog, right? You got to have that information to go through. So we'll do that. We'll set it up. We'll set the listener up on port 80. So we basically now have a web server running there for all intents and purposes, although it's not going to serve anything. So if we were to come over here and we did Netcat, why is it way over there? All right, Netcat 192.168.
So the IP address, is that the...
Cali box.
Okay.
Yeah, I'm basically telling it, go send it here. Send it to this machine. And it was 156, right? And I think we'll just put port 80 there. So if we do that, we get a connection. All right, let's see if we can get out of it. And it killed the connection over here. That's there's a switch you can throw to make it not kill the connection, to make it persistent. So basically, I'll come back over here. We'll start it back up. Maybe. There we go. Then we'll pop back over here. And we'll do that, but instead of just opening up a connection so we can just send a bit stream, okay, byte by byte to and from the machines, we're going to do something else. We're going to use the, what is that, less than sign? Okay, we're going to use that sign, and then we're going to type in that file name, ps.txt. All right, because that's a lot of text in there. I don't know how many lines it is. It's hundreds of lines. All right, we just transferred it. Okay, that fast.
That was instant.
Yeah, pretty much. Yeah, so it makes it real easy, you know, if you've got a file over there, to transfer it over here.
Is that how you usually like transfer files?
It's a way. I mean, most of the time we would use SSH. You know, we would use Secure Shell and do it, but a lot of times Secure Shell is blocked, so you can't make that outbound connection from the company, because they block it, because they know that that's probably not a good thing to have open. But port 80 and port 443, they're not even going to look at that. You know, they just allow it because they know their people have to be able to get to the web, to the internet.
So would it block it if it was a different port?
Yeah, like we actually use like port 123, it'd probably block that.
So, if your computer didn't have any outward ports open, you would be able to be hacked, except with like emails or things. But
Yeah, I mean, right now we're exfiltrating data, right? We're moving the data from one machine that we've compromised off. So.
But if you didn't have any outward ports open, you wouldn't be able to do that.
Right. If the company, you know, if they got a firewall set up and they're like, yeah, okay, nobody is going to get out of our network, period. Okay, no email, no DNS, no surfing the web, no nothing. Okay, this wouldn't work. So that's why we would use ports that are normally left open, because without port 80 and 443 open, nobody at that company can surf the internet, which means they can't go to their vendors, they can't go to their business partners, they can't do any of that stuff. So they typically leave those open, which is real handy for us. Now, what if that, you know, this is a text file. What if it's a binary file? Do you think that would transfer? Like, say, let's see if we got one on here. All right, so let's go to bin. What is table? A little bit better. At least it won't smack the wall now. user bin. Let's see if there's anything in there we can use. There's a lot of stuff. See, zip is a nice small file. All right, so if we do more zip, okay, now this is, bin is your binary directory, okay, in Unix. That's where your binary files, i.e. executables, i.e. programs, are stored. So if we do this, okay, it's not a text file, right? And it's telling us that. So let's do this. Let's cat it and see if let's force it to spew something. There you go. So that's a binary file, okay? You're seeing the actual non-printable characters, okay? So what if we wanted to move that over here? Let's see what would happen. Let's do this, okay? And we know we're going to send a binary file between it. So let's do this. Zip, or netcat-l port 80. And we're going to send this to a file called zip1, okay? So now all the data that we send over there is going to be sent to a file we called zip1. Now we're going to jump back over here and we're going to do back to our netcat there. And instead of putting in ps.txt, we're just going to put in zip. All right, so let's see what happens. Looks like it worked. Okay, nothing happened down there because it's going to a file. But if we kill the session now, okay, now if we do a ls, not there, but on this machine, whoa, look, there's a zip1 file. I wonder what it looks like. Oh, wow, look at that.
Wow.
Okay, so we just transferred an executable file from one machine to another. So no matter what that file was on the victim machine, we just sent it through Netcat extremely quickly to our infrastructure. Okay, so now on our, on the bad guy's network, we now have the files. So if that was their secret sauce, for the secret recipe for their, chicken recipe, we now have it on the bad guy's machines. All right, so a lot we can do there. Now, looking at this file, what is that? Can y'all tell what that is? Let's see.
Information in computer language.
Wow.
So if we look through all this, I mean, there's a lot of junk in there, right?
Stuff that needs hashcat.
Huh?
Stuff that needs hashcat.
No, not really. Hashcat. There might be a password in here that we could use hashcat to get for us. But if you go through this, you're just seeing all this non-printable text, right? Oh, look, here's some printable stuff. Okay, so a lot of this stuff is.
Oh my eyes.
Yep.
Oh, I don't know how.
So, if let's say there's two bad guys working, and one of them's on the machine. Okay, he's the operator that's exploited the machine is on it, and the other guy's on the Kali box, and his job is to sit there and say, what is this stuff? What am I getting? So how do I classify it and put it in a folder so we can find it later, right? You could do this, file, okay, there's another Unix command that's handy, zip1. It's an ELF 64-bit LSB Pi executable, ARM architecture, version 1, system V, dynamically linked interpreter, blah, 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 for Linux. Okay? So tells us a little bit. We know it's an executable that'll run on Linux, specifically on the ARM architecture. Okay, so Apple Silicon. All right. Now let's see, what else can we do? There's another command that we can type in called strings. Okay, and basically what strings does is it looks for ASCII strings, things that are ASCII. Okay, not these weird funky characters that are all spread out through there, right? So if we do strings zip1, it's going to give us all the strings that it found in there. And this may give us a clue as to what it is. There's a lot of stuff in here. There's, you see zip in there, zip diagnostics. I mean, just based on this right here, you can probably start getting an idea of what it is.
Does it just make a zip file?
That's exactly what it is, the zip program. It'll create a zip file, it'll unzip a file, it'll do all that. But you can go through, and this is out of that whole program, okay, now it's several megabytes probably. There's some ASCII scattered throughout that whole thing. And some of it might be like right here. It's telling you can see in no event shall info zip or its contributors be held liable for any direct or indirect stuff. So that pretty much tells you what the file is right there, right? The guys that wrote it. And then look right up in here. Now you get some options, self-extractor. So as you go up, you're getting enough information to know that this is zip. So I wonder if it works. We'd have to test that, right? So we can see right there that we got just read and write permission on that file. So it wouldn't be able to execute. But if we did a chmod on it, plus X, okay, that basically, get rid of that equal, we're making it executable by doing that command on it. And then we put the file name out there, zip1. Okay, now if we do an ls-al, what? Why did that not work?
You don't have push.
Yeah, it did.
Oh, yeah, but it didn't throw an error message. That's a bug. Okay, so now let's do the ls. Still not. That's funny. Why is it not letting us change the permissions on it? Let's do it a different way. There we go. It doesn't like the -X.
So -X is 7 to the 7?
Pretty much. -X makes it executable. So
777. Wow, all the.
yes, it does. You never want to do that. Because now anybody, because remember how you got the groups and it's all in binary, right? So you got the owner, the group, and then everyone else, right? So if we do 7, that would be 1 plus 2 plus 4, right? So the first bit is 1, second bit's 2, third bit's 4. So that's 7. So about 777 is going to make it executable by everybody in the world that can touch it. So what if we just execute that now?
Wait, so where did you get this file? Like, did you make this up or did you just...
No, this is an actual zip file that Unix uses.
And you're going to delete it?
No, I changed the name, zip1. So, but what we're going to do is we're going to run it right now. Let's see if it works. Just to verify that we actually were able to transfer every bit of that file from one system to the other one and keep it intact. So if we do // which means execute in this directory, and then we type in zip1, oh, it gives us a message that says you're not using it right. You got to do this, right? So we want to zip a file. Let's see what we got here. ls.
2008?
Yeah, it's been around a while. All right, so let's do eda.text. What is that? Probably need to get that extra character out of there, huh? Okay, this is a password file, all right? So, whole bunch of stuff. Let's zip that.
In this file.
Huh?
In this file.
Yeah. So, if we do /zip1 and put in the source file. Probably just as a very basics, you're going to need a source file, then what you're going to call it, destination file. So we'll do eda.text and then eda.zip. Zip file error, zip file structure failed. What do we need to do? Let's see, let's try this again. Zip1. We need to create a file or something. It's options. This might be a little bit different than just regular zip.
So maybe it's something that we should not be deleting.
Oh, we're not going to delete it. We left it over there. It's good. It's all good. See if now let's just do the regular zip here without the 1. And we get yeah, it should work. So let's do it the other way. Yeah, there we go. I had it backwards. So it works. So zip1, which is the file we moved from Ubuntu over to Kali, okay? We just used it to make a zip file. And eda.zip is that red one there. So we just created the file. So it works. We're able to literally transfer an executable from one system to another one. And now, obviously, if this was Windows, it probably wouldn't run on it. But because they're both Linux, it ran. But that just proves that we actually were able to get it. So there's a lot that we can do with that file, or with that command with Netcat, okay? So, interestingly enough, now that we have this, we got zip1 there, let's say that we now have taken that zip file that was running over on Ubuntu, we moved it to Kali, and now we've added some extra stuff to it. Let's say we went through and recompiled it, or made some modifications to it, or we created a zip file that we want to replace their zip file with. Okay, so let's say we modified zip to every time they encrypt or they zipped a file, that it would send a copy of that file through Netcat back to someplace else, right? Back to our Kali box, because we want to get a copy of everything they're doing on that machine with this utility. Okay, we make those changes on our system, and while let's log back in. All right, so we could do this, we could start Netcat on this guy. Let's see what the IP address is first. All right, this one is 79. So we can start Netcat over here, tell it to listen on port 80. Okay, and say we want the output to go to a file called zip1. Okay. Permission denied, of course. Yep. All right. Oh, it's already got a web server running on it. Okay, so let's do this. Let's do port 123. How's that just for... So now we've got port 123 listening. And over here, we can just do this. Actually, I didn't redirect it, so let's just make sure it's working. So then we'll do it again.
So now it's reversed?
Huh?
So now it's reversed?
Yeah, we're reversing it so we can send something from our Kali box to the victim machine, right? And port 1, 2, 3. Okay, so now if we just type some junk over here and hit enter, you'll see it pop up over there. Okay, so we got our connections working. We've tested it. So now let's kill this. And we're going to start it again, but this time we're going to redirect it to zip 1 because we're going to transfer our file. So over here, let's kill this. Do it again. Space. And we're going to send zip 1 over. Okay. Oh, I should probably hit enter over here. And put what? Oh, I'm in the bin directory, that's why. Let's change directories here. All right. We can write to that one. And let's do this one again. All right. So if we kill this now, and then we come over here and look, we've got zip 1 over there now. So we've moved it over. So now we can take our Trojanized zip file, okay, and we can now replace it with the one that's in bin, okay, which is where they keep all the binaries. And we now have a Trojan piece of malware basically sitting on the box. So it's real easy to move files back and forth with Netcat. Now, the thing that the defenders need to do is detect whenever Netcat's running, right? So let's do this.
Does it leave like a big footprint, whatever?
Exactly. MD5 sum or SHA-256, okay, you can detect that with that. So we're going to MD5 sum slash user slash bin slash, we got Netcat in here, NC.
Yeah.
Let's try NC and see if it'll work.
What does the red signify?
Hang on a second, I'll tell you. Let's see. So there, we've got the hash file for Netcat, right? Now, we could, if we had an EDR on the network, which my company, you know, we use CrowdStrike as our EDR. So I could go into CrowdStrike, and if I knew this was the latest release of Netcat, and we wanted to make sure we got an alert anytime any computer on our network ran that file, we just put that into detection and we get an alert. You know, we got a group of analysts that are sitting there and they're watching this stuff all day long. And if someone tries to run that command, the CrowdStrike EDR will see that and say, oh, nope, I don't think so. And we can have it delete it automatically or just kill the file so it can't run to keep the bad guys from doing exactly what we just did. So, all right, you wanted to know what the red ones were over there. Let's see. That was in user bin. Okay, so you see the green ones, that signifies that it's executable. Okay, that means you can run that command. That's an actual binary command. The blue ones there are symlinks. Okay, so you see that top one there where it says Z to John, and then you got an arrow, and then it says /shared/John/ Z to John.py for a Python script. That's just redirecting it, saying this command, if somebody types in Z to John as a command, run it from this directory as that file. So it's just redirecting you to a different location. Now let's see if you said there was a red one in there.
They were highlighted red, so I think it was.
Oh, if it's highlighted red, that might have been me searching for NC. Let's see. Let's run that command again. Those red ones right there? Yeah, those are probably deleted. See, new group. Let's see if we can see what that is. We don't want MD5 that. Let's just do a. Sometimes it'll mean that it's not there or it's been moved. But the way to find that is yeah, I think that is not there. Yeah, it didn't do anything, so.
It's been eliminated.
Yes, it's there, but it's not really there.
It exists, but it's not there.
Yep. So, y'all find any uses for Netcat yet?
Chat.
Yeah, Netcat's pretty cool. I put a video up too. You guys can watch it. That kind of goes through it, through some other commands or other aspects of it. And just if you want to practice at home, you know, compromise your parents' computer, put, you know, move files to and from it. No, I didn't say do that. But yeah, practice between your VMs. You know, that's why we're using multiple VMs. So, all right, what else can we talk about with Netcat?
Vim.
Huh?
There's the Vim executable in there, so I did Vim on the Vim file.
Okay.
It's a bunch of random characters.
Oh yeah, it's giving you the hex on. Now, that's a good thing that we can actually touch on real quick. All right, so if we do cat /user bin /vim, okay, you see there's a whole bunch of non-printable characters, right? But what if you want to kind of get an idea of what Vim is, right? I mean, you can, yes, there we go. Sometimes when you're going through like non-printable ASCII characters with a tool that's expecting ASCII characters, it'll do some weird stuff at the bottom. Like right then it printed some stuff, so then I had to hit escape to get it out of it, or hit enter. So if we do this, do a hex dump -C, and then that file /user/bin/vim, and let's pipe that to more. All right, so now what you're getting is on the column on the far left, that's the line number, okay? So starts with line 0, then we go to line 10, which is the first one in this one. But, you know, it just kind of does that. Okay, you can remember how that other one, when we looked at it, it said when we did a file command on it, it said it was an ELF file, ELF. What do you see right here in the center column is the hex, okay, the base 16 output of the file, because computers don't really speak in written language like we do. Right? It doesn't use ASCII characters. That's something that they put in computers to make them usable for us because we don't understand numbers. So this is the hex representation of it. Okay, and hex is 0 through 9 and A through F. Okay, so like 7F, okay, is the numerical equivalent of the numbers. So F is 16. Okay, so count, 0 through 9. Okay, then A is 10, B is 11, C is 12, and it goes to F, which is 16. All All right, so this is giving you the ASCII in the right column. Okay, so if we start going down through this, okay, look, there's some ASCII. Remember when we did that strings command and it gave us the ASCII print or the ASCII printable characters? That's what was in this right column. So when you do a hex dump, you can actually see the literal code of what's there, and it doesn't give you the gibberish. You know, you can actually kind of read this. And we just keep rolling down. Oop, there's some more ASCII. Okay, so this can actually translate directly. So like, if I can't do it in here and show you, but you see the 00 right here? So I can get it to highlight both of them. All right, see that 00 right there? That's the period over here. Okay, right there. That's 00 represents that period mark. All right. So
each like two numbers or letters represent one character?
Yes.
Okay.
So, and if you go through, there's you can get some printable or there are conversion like maps, right? It'll show you the ASCII character, the hexadecimal representation of it, you know, and it'll kind of give it to you in that chart, and you can use it to go through some of this stuff. Like, let's see, on this one, there's two T's here.
Is that 74, 74?
Hmm?
Is that 74, 74?
I'm believing it probably is. You have to like look over here. Right there. See, because this line right here, you've got like 8 hex characters, and then you got a column, and then you got 8 more hex characters. That's splitting this line over here in half. So yes, the TT is the 7474 right here. So it's not like a lot of people will get really confused on this. They'll look at this line over here, and they won't. When they're looking to try and translate it, they won't look past the second column. You know what I'm saying? They just kind of look like they'll try to translate this right here, and they'll just look at this part right here. They won't realize that it starts over here and goes over. So
That makes things complicated.
it does. But being able to view things in hexadecimal is how it's going to be transferred over the wire, okay? Because, you know, when we transferred that binary file with Netcat, it transmitted it this way, this hexadecimal. If we actually looked at Wireshark and looked at the actual packet that was being passed, the string, you would literally see it. Actually, that's something we can do to be pretty cool, actually.
So is 74 always going to be T, or is it just depends on?
Depends on whether or not it's uppercase or lowercase.
Oh my goodness.
But yes, for most part, a lowercase t will always be 74.
I see a lot
So-
of 74s.
Yeah, a lot of t's in there. T is a commonly used character.
Was it S and T?
Something like that, yeah.
It's common. And the other is just common.
Yeah, look, right there's an S and a T together, twice.
So 72.
Yep. So 73 is the S, 74 is the T.
Okay, where's the E?
So let's see here. Let's start Wireshark.
UP.
All right, and we're going to do a capture. We're just going to let it start running real quick. And get back over to this. All right. Oh boy. NC-L, we'll just type it out. And we'll do port 123 again. Or to make it easier, 1, 2, 3, 4. How's that? Okay. And then we'll come back over here to, if I can get it to come up, where's it at down here? All right. All right, and let's connect over here and let's send something. All right, and let's just change this port. All right, so boom. All right, we got to be in the right directory. Okay, so the file's over there, right? But now let's go look at it in Wireshark. Let's stop the recording. And let's find that.
Can you look at the file in Wireshark?
Absolutely.
Whoa, that's cool.
So let's follow this TCP stream. Okay, there's your file. Okay, now if we follow this stream, we can actually extract that file with Wireshark. So, okay, by monitoring, by sniffing the wire, we can actually extract this file as a binary file.
How do you extract it?
Now, that's not in those neat organized columns anymore.
No, it's not. But if we actually look at the packet, this is showing it to you the way that Netcat saw it on both ends. But if we come over here and let's look at this right here, look at the bottom right. That's how that's how it came across the wire. It didn't come across in this unorganized mess. It come across like this. So, pretty cool, huh? But what we can do is, if you're following an HTTP stream, you can just go and extract the components from the HTTP stream. So, like if you're sniffing the network at your house, right? And your little brother is surfing the internet, and he's going to a comic site, right? And you want to see what he's looking at, you can literally extract all the pictures, all the video and stuff out of that. Or if someone's watching YouTube and you want to save the video and you don't have YouTube Premium and you can't download it, you can just literally extract the video out of the stream and just save it to your hard drive. So it's pretty cool. But that's it. I'll probably put an exercise up to mess with Netcat. I'll probably do it this afternoon. So just if you guys can practice with that. It's pretty cool. You don't even have to have two machines. You can just do one machine. You can just open up two terminal sessions. Like even in your Mac, just open up a terminal session in your Mac, get a copy of Netcat on there, and then open another session and just send files between the sessions. So
I found one with the name Patrick Sheldon, and then it says there's a little thing in the CPU local. So
okay.
I found the name.
Priority.
So it's fun. This is a lot. It's a lot of fun when you start getting into the nuts and bolts of how all this stuff works. All righty. So I guess that's it. Let me stop this here. Yep.